go. So you guys have been looking for anyone who's absent today or just checking out the video. You were looking at the very end of 9.4b homework, number 28 and 34, checking your answers. But now I am in the book. Boop. Is there anything you want to see? 25, 26, 27, 28, 29, 33, or 34? That end of homework that got hard 2 nights ago that you were supposed to finish up last night. We're rocking it? We're okay? The number in front didn't mess everything up?
I didn't get to the last one.
The 34?
What, like 7?
Oh, that's the homework that's not due until tomorrow. So you're okay, Jonathan. We're going to finish examples on that worksheet. But we can peek at 78 and 79 because it's different, right? Okay. That's actually kind of like a leading into 9.5 sort of. But you're right. It seems super weird and out there. Anything from 9.4b, though? 34. Okay. I wanted to at least get one of these numbers in front. So, Kayla, thank you. Let's look at number 27, and then we'll peek at 34. For those of you guys that are like, I'm good.
Can you do 43? Wait.
Yes, but I'll probably be doing that one tomorrow since we're going to finish up examples today. No, you're good. You're good. That means that you were trying to be totally on top of it. I didn't change RunWeb until after the meeting yesterday. So you might not have seen it right away. Andrew. Okay. We'll do 27, then go peek at 33 and 34. Because I think those ones you were trying to find the mistake, right?
Yeah.
Okay. All right. Number 27. All right. 27, in my opinion, is the hardest type of completing the square problem. Okay? And I actually don't know. Did this one end up in a decimal or in a nice answer when you guys checked it in the back of the book? Okay, so it doesn't even, like, you need your calculator to throw in the square root. I'm going to get my calculator opening. As I do this, some of you are just kind of sitting there, and I don't really see the homework out from 2 nights ago that you finished last night, or anything else out that you guys can actually write on. So can you either get out for me the 9.4b worksheet, because this is an example like 11, 12, or 13, or just turn to the back of your homework spiral, that workspace. Can you just do this problem with us? Because I'm a little worried if you don't have homework out that you just didn't do it. And this is the hardest type. This is the one that we really practiced on yesterday. So you can go to the worksheet and add it in at the end. It's like 11, 12, 13. It's like that one. Or you can just go to the back of your homework spiral just so you have like some workspace, some paper to work on. Because this is a really hard one, and I think it would be really beneficial for most of us to probably do another really hard example and make our way through it. If this was just a general quadratic problem, Andrew and Everest is time to focus. We would go ahead and multiply A times C and move that up here. It'd be 88, and we would be looking for factors that multiply to be 88 and add to be 20, but Kayla just told me that the answers are decimals, which means we won't even find it. If answers are decimals, that factoring x does not work, because this only finds for me the nice, even, whole number, positive or negative. I'm not going to find it if it's a decimal. So instead, what we say is number 44, not number 44, but that third term. 44, you're not good enough. Not that he's not good enough, but he's not going to get me to the answer being in that spot. That's not his proper position. It's standard form, that's good, but I can't factor. So I'm going to move that 44 over because we're going to use completing the square that says we need to put our own C in. Remember, it's us being creative and saying we're making what we need in order to be able to solve. So the 44, I'm sorry, bud. We need to move you to the other side. And he's going to be able to accomplish his job much better over there. I'm going to do it now, but we could have done that earlier. Kayla's saying that there's a 2 in front, and that's kind of what messes us up. Andrew asked yesterday if we could divide it early, and I basically said no, and here's the reason why. I'm afraid a lot of you would have divided right here and nowhere else, and these little guys need to be divided by 2 also. So because I think that a lot of people would make mistakes in doing it early, what I do, just to be safe, is I just save him until I see a GCF. And also, Kayla, it doesn't always go into this number so nicely. It does this time. 2 goes into all of them. But sometimes it only goes in these 2, so I'm just kind of safer than sorry, letting you be ready for any problems. But now at this point, you're right, because completing the square, we don't want a number in front, so we're going to go ahead and factor out the 2. And remember, when you factor, aren't you dividing? But when you factor, you divide everybody in those parentheses. We divide everybody in those parentheses. Andrew?
So I kind of did, so I did like the dividing, but I also divided the negative.
And I'm about to, I just wasn't ready quite yet, because when I factor it out, the only way it gets to the other side is when I move it. Does that make sense?
Yeah.
So I'm just dividing to pull it out, and now I'm going ahead and moving over. But it could be that you kind of devise your own system, as long as, kind of like Caleb said, you make sure everything gets divided by 2, you're keeping it legal, and your answers should be matching up. But if you notice that you're trying to do it like a little different way and the answers aren't matching up, that's when we have to be careful and get that. Is that cool? Yeah. Armando?
Put the 2 on the outside.
Oh, because I looked at these 2 in here, and I saw in my completing the square, remember, this guy kind of comes out of thin air. Not literally, it comes from right here, but this guy's not there. We don't like having a number in front, and technically, to be honest, it's not legal to have a number be in front to complete the square the way we've been doing. So I'm saying, who's that guy in front? 2. And I'm saying, I need to get him away. And the way to get him away from polynomials is to factor GCFs out. So I saw that 2 was a GCF. I factored it out. And whenever we factor something out or away from a polynomial, we're undistributing, we're dividing. Does that make sense? There you go. So I pulled that GCF out. Now I have a 1x squared. Well, and I moved the 2 over, like Andrew was saying. And this looks like, ooh, I don't want it to be yellow. Yikes. I pull that GCF out, and I have x squared plus 10x equals negative 22, and my computer is at go team. There we go. Now, why have I left a big old awkward space? I need to add in my other number, and the number I need to add in is the one I'm going to go, come on, you guys have a square in your head, right? You have a square in your head? I'm going to throw in my x squared, my 5x, my 5x. Why is Andrew saying 25? Because that's the number that completes the square. I put it on one side, I put it on the other to keep everything, remember, keep it balanced. And I'm so close to being done. What was the purpose of all of this? What can I do once I complete the square? Pull out, pull out, pull out, pull out. Pull out your x and your constants, and I can go ahead and always write the reason I complete the square. Always write the factors as a perfect square. So what would the factors be of x squared plus 10x plus 25? X plus 5. So you can pull out an x, pull out a 5, pull out an x, pull out a 5. They're both x plus 5, so I can make this x plus 5 squared. And that's what was on the quiz from last Friday. At the very, very end when I said, don't just complete the square, also factor it. That was kind of the point. And now we're to that nice form of an equation that you guys liked and you guys circled saying, give me that all day. I would rather have it like that because what can we do to both sides now that there's a perfect square? Radical. We can take the square root. What do square roots do to squares? Cancel them out. Now here's what gets a little tricky. If you don't remember to slow down. Wait, why am I saying slow down? What should you put with that square root of x plus 5?
Absolutely.
Good. I'm going to come up here because I'm running out of room and my screen just went weird. Slowing down to get my absolute value. Ooh, hey, it's one of those nasty ones. Let's go ahead and go get his square root. Hopefully you guys know how to use your calculator. And if not, hopefully you get here early enough to get a calculator of your choice that is doing square roots with decimals for the test or for the quiz. If not, get your own. Be able to use the same calculator every time. 1.73? Good. So 1.7, oops, that's not it. 1.73. We can go ahead and say x plus 5 is equal to, what did absolute values do? Yeah, negative and a positive. So I'm going to have a positive 1.73, and I'm going to have a negative 1.73. Forgot the negative. Because remember, that's what the square root of 3 is. So I can use a positive one or a negative one. And now, man, I can just coast to the end. Because what's the last step for both? Subtract 5 and be done. Subtract 5. And be done. How we doing? Is that a good look or a bad look?
I forgot to radical 3.
Oh,
I
bummer.
thought you couldn't do it.
Well, you can't do the radical 3 as a nice even number, but we knew it wasn't going to be nice even. Kayla warned us there were decimals. So we can just, when the directions say solve to the nearest hundredth, it's okay. It's okay, get the decimals. Jerry? Yes, you may. Okay, if you tracked with that, and if you're like, okay, I think I can do the number in front, or at least I did it with you just now, all the way to the end. Give me a thumbs up, go fast. Did you make it there with me? Okay, about half the class. The rest of you guys, it gets tricky right when there is a number in front. And there is definitely a method to the madness. There's a system. There's a system, so you got to get practicing. Be practicing with me. Be practicing in homework. Be coming in and letting me just give you a whiteboard and give you a problem to see if you really have it before the quiz, before the test. But then Andrew and Kayla both were like, 33 and 34. I mean, Andrew didn't like 33, Kayla didn't like 34. These ones are kind of tricky sometimes because usually it kind of looks good until it doesn't, and you're trying to figure out where it goes weird or where it goes wrong. Now, Andrew, this is kind of like what you were saying. The 10 is kind of like a 3. And if they're not going to decimals, you're right. You're kind of, it's not that it's illegal to do. There's just no nice answer to write. So sometimes some of the answers, if you're not going to your calculator, they just leave the square root in there saying, well, it's some decimal. I don't know what it is without my calculator, so I'm just going to write it. But it's always legal to take the square root. It's just not always a pretty number. Okay? But in this one, hold on. I think, oh wait, hold on. Somebody was able to find a mistake in 33. What's the mistake? It shows up pretty quick and pretty fast. Okay, so I think they completed their square, and I think they got the 16 from the square. But yeah, Trey's saying it's only on one side, and in algebra, do we ever just add to one side? No, we also have to add to the other. So where did they go wrong? Right here. They should have added, and that's why I put a little blank on both sides to remind me I need it to stay balanced. Whenever you guys take chemistry, balancing equations is kind of an important thing. When you add 16 on one side, you got to add it on the other. So, I mean, their math was actually really, really good, except all this time it shouldn't have been a 10. It should have been a 26. And you guys might be like, ooh, 26, is that nice? 2 and 13, I don't think there are any perfect squares in there. So the final answer would have just been super similar to what they had, and yet different. It would have been -4 plus or minus root 26. That makes sense, Andrew?
Yeah, cool.
But really easy to miss if you understand complete the square. You're like, wait, they did it good. They did it right. It was, oh, they didn't put it on that side. And then Kayla, 34 was one of those numbers in front ones, which made it kind of hard. Hey, they did what I did. They didn't like their third number, so they moved it over. They went to go find, what did they not do before completing their square that they probably should have? What did we do that they didn't?
Plus.
No, 2x. Remember, we're supposed to have an x squared, and we're supposed to have an x. But question, what's supposed to be in front? A 1x squared, right? So, yeah, who wasn't supposed to stick around? The 2. So actually, they completed the square too quickly. You're not supposed to have that 2 in front. So then I would do that factoring out step. And that factoring out step, and there's different ways of doing it. Andrew, you're kind of, I think what you're doing is like divide by 2, divide by 2, divide by 2. That's legal. It really is. I'm just showing the math of what that actually means, and that where, Armando, you were asking this. I'm going to pull that GCF of a 2 out. And when I pull it out, remember, what I'm doing is I'm dividing. And so actually, both of those 2's go away just to be a 1x squared. Oh, it's a minus, sorry. And a minus 1x. And so Andrew, remember, now I'm gonna move it over to the other side, yeah? Now I'm gonna divide, now I'm gonna divide. And Kayla, now it's ready for me to complete the square. Because I have my x squared minus 1x. There's my blank for my square. I get my 4 over 2 is 2. I need the blank on the other side to keep it balanced. And so then when we go to our square, actually our square is going to be kind of nasty, because question, what happens if you split 1 in half? Not nothing, but it's not going to be like a one of those big nice numbers you guys are used to. Guys in the back, calm it down. I'm going to have my x squared, and then I think it's going to be negative, doesn't negative 1/2 and negative 1/2 make negative 1?
Yeah.
Ugh. So what's my complete the square number? No.
X.
We multiply. What's 1/2? Negative 1/2 times negative 1/2.
Oh, 1/4.
It's a fraction. Not impossible. Good. Not impossible, it's just a fraction. So I'm going to have to put a 1/4 right here. My computer stops being mad. And a 1/4 right there. And I think, did they tell you to actually... Oh, it says to correct the error. Yeah, we're supposed to be solving. So then at this point, we would go ahead and factor. But the nice thing is we don't have to stress here. Just look. X comes out and a negative 1/2 comes out with a squared. And I would end up with, 2 plus a 4th. I think I need to make 2 into 8/4 plus 1/4 to make 9/4. And I'm going to go ahead, because we're kind of running out of room. It's getting really messy. Where we've gotten is having the factors of x minus 1/2 squared equals 9 over 4. Why am I getting my yellow out? What are we about to do to both sides?
Solve.
Solve, but we need to get that radical in there to solve, right?
Right.
And what's a radical do?
Take
Cancel out the square, but why am I saying slow down? What do you need to write? Absolute values. And then, oh, hey, we're going back to section 9.1 for a second, because I think I actually know some of these guys. Isn't 9 3 squared and 4 2 squared? So I'm going to actually be able to take the square root of 9 and take the square root of 4. The absolute value slows me down in order to write one positive and one negative. And at this point, all I have to do is, they even have common denominators. I get 4 over 2, which is actually a nice number. And I get negative 2 over 2, which is also a nice number. Whew. Dun, 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 dun.
A lot of words.
Yeah, you know what? With these nice numbers, you know what's really crazy? I'm pretty sure the X method, for once, would have been easier. Levi, you were the one that kind of liked factoring back when everybody else was saying, no, please give me this one instead. Let's check this real fast. If we were to factor this guy, try and get him up there. We would have actually put a times c, negative 8 up here, and we would have put negative 2 in the middle. Doesn't 4 and 2 make 2?
Yes.
Oh. Actually, we could do a negative and a positive to make a negative, and I think it works. You're right, sometimes the signs are off. I think this time it would work. Because then we could go ahead and throw in an x squared and a negative 4x and a 2x and a negative 2. And I would pull out an x and pull out an x and pull out a 2 and pull out a negative 2. Huh. Oh, it's not an x squared. My bad. It's a 2x squared. That's why I got messed up. My bad. I have 2x squared minus 4x plus 2x minus 4. Yikes. I was not even following. I didn't look at that guy at all. That's dangerous. You're not supposed to look at the x for those fill-ins. You're supposed to look at the original problem. Guys, you okay? Can we calm it down?
Oh, yeah.
Thank you. So I can pull out a 2x, and I can pull out a 2, and I can pull out a 2, and I can pull out a negative 1. I have my minus 1 right there. Oh, it's a 4. It's been too long since I've actually done the boxes of factoring. There we go. The -4 is in common, the 2x is in common, the 2x is in common, and the 2 is in common. So then we could go ahead and, like Moses splitting the Red Sea, we would end up with 2x equals -2, x equals -1, 2x minus 4 equals 0, 2x equals 4, x equals 2. Why am I doing this? To be honest, the complete the square did work, but you guys are right, because some of you were like, man, that was a beast of a problem. The old school method in this one would have been easier, but whenever we have decimals, the old school method doesn't even possibly work. So I was just trying to show, especially for Levi and maybe the other 1 or 2 of you that are like, oh yeah, that factoring thing, like I was actually pretty good at that. If the factoring x works, you can get to the final answer maybe a simpler way, but remember with decimal ones, the x doesn't even work. There is no way to get there without completing the square. Isaiah?
May I please go to the bathroom?
Yes.
Thank you.
Everest?
I was gonna ask.
Too bad. Oh, wait. Ken? And maybe pay a little bit closer attention so that I'm more prone to say yes. Okay, we have a worksheet though, guys. We got to go over all of your homework questions, and some of them were tricky. Caleb, this one, I think the mistake, now that we've practiced this little A in front, wasn't too hard to find, but completing the square was hard. And then Andrew on this one, I mean, their work looked great if you didn't look at the other side and realize what was missing, right? It's tricky.
Yeah.
It's tricky. But we have tonight section 9.4C homework. So actually, let's pull that up really fast because, Jonathan, you were working on that last night, and you said there were a couple places that got tricky. We're going to go back into our notes and do number 15, or sorry, into our worksheet to do number 15. So you guys can get that 9.4C worksheet ready to go. Remember, I'm grading all these homeworks and worksheets tomorrow. But Jonathan, homework tonight is 37 to 43. Some of you might even want to take a picture of this because you might be able to work on it at different points during today. So here's 37 to 43. This is where homework starts. Or maybe even you could be working on it in class. If you start getting the hang of it, that'd be kind of cool. Here's tonight's homework, 37 to 43. Some of you started it last night, but we didn't do a lot of examples, hence why we're taking another day. And we need to finish our worksheet. But 37 to 40, those ones are kind of just making them match, which could be really, really hard, except I think there are some patterns. Like, I only see 2 frowny ones and 2 smiley ones. Concave down ones and concave up ones. I think there are only 2 negative guys and 2 positive guys. Maybe we can already get like down to a 50-50 chance of getting it right. And I think I can see my vertices very, very, very clearly in each of these pictures. And if you guys have your worksheet out, that's kind of the point of the worksheet, is finding the vertex. So if you can figure out which of these go with the up ones and which of these go with the down ones, then you start to figure out, okay, which of you has a vertex at -2, or at 4, or at 1, or at -3. Huh. And then as we keep going down here, Jonathan, in 41 to 43, this is very similar to what we're doing in the worksheets. We're going to practice that a little bit more. But then he also mentioned, he also mentioned 78 and 79, right? Or 70, what is it? Yeah, 78 and 79. Let me go show you guys that, because some of you might want to take a picture of these ones, because this is the very, very end of homework. We don't normally do these ones, just because we kind of run out of time, and I try not to give you guys too big of homework assignments. But do you see that it's actually supposed to be reviewing what you learned before? And I just kind of told you, like, hey, it's actually going to help us in what comes next. 78 and 79, you guys see an A, a B, and a C. An A, a B, and a C. And where are they telling you to plug it in? They didn't use the snazzy term, but they should have. You're substituting. You're substituting. You're plugging in. You're going to figure out who's B and put them in that spot and square them. Minus 4 times who's A, who's C, and then you have to think PEMDAS. So what this is asking is, can you plug it in? Can you do substitution and PEMDAS? That's it. No completing the square. Can you do substitution and then PEMDAS to simplify it down to a single answer? And Maybe it's like what Andrew said earlier. Maybe it's one of those nasty square root of 3, square root of 10, like one of those nasty ones that you can't really go further without your calculator. Or maybe it's one of like square root of 25 and you can. Jonathan.
Okay, so when we plug it in, do we have to like, is it like plus in between like the numbers? Because like.
No, it's going to be times. So these ones, like 4AC, let me show you. You're going to put in B to get it squared, and then minus, and when you put in A and you put in C, think of it this way. PEMDAS says parentheses, which is actually kind of the square root. It says start where they all are. Exponent, I'm going to square first. Multiply, I'm going to do 4 times this guy times that guy. The very last thing is 1 minus. Is 1 subtraction. Is that cool?
Yeah.
Okay. So let's get into our worksheet because we just talked about, and I think, Jonathan, you actually asked about 43. The hardest ones in homework, I think, are the ones like the examples we need to finish. So here we go. Number 15, we have number 14 that we did yesterday. He's on the screen. I don't know about you guys. It is warm in this room. I'm going to open the door. The sun's shining, which is good and bad all at the same time. What do you see that we did in number 14 that we can start by doing in number 15? The box? Okay. So we're trying to answer this down here. Do you guys remember the very first? Oh, hey, I numbered it. What's the very first thing I did yesterday in number 14? I looked at the max or min. That's the first thing I looked at because that's an easy question. That's an easy question. Okay, worksheet number 15. How did we yesterday, and to be honest, there was no work on the board yesterday when I did number 1. How did we figure out that number 1 or number 14 had a minimum without any work whatsoever? Because technically the snazzy name is the concavity, but yeah, it's the way the parabola was facing. So wait a minute, this guy, is he going to be facing up or down? How do you know? I agree. Good. Good, good, good. Leading term is positive. He's facing up. Since he's facing up, where is his vertex? Perfect. Can you guys go to number 16 and 17? Can you figure out if it's a max or min for those ones? 16 and 17. Think about the picture. Think about the leading coefficient. Max or min? Now, hold on. What do you guys see in number 16? What have you figured out? Is he facing up or facing down?
Down.
Good. So then, what am I going to circle? Good, good, good. You have to think about it. Otherwise, I don't know. My brain hears down, and I'm like, oh, it's a min. No, no, the picture. If it's concave down, if it's like a mountain, it's going to have a peak. It's going to have a highest part. If it's like a valley, it's going to have a lowest part. How about number 17? Up or down?
Down. And up.
Why is it up? It's the sign of the very first term.
It's positive.
Good. So I have concave up. And since it's up, what am I going to circle?
Yeah.
Good. I think the picture makes a world of difference and makes that question really easy. The picture makes it really easy. Okay, now hold on. We still have to figure out this whole value thing. So let's go back to number 14 and say, all right. We started doing work. If you guys want, though, ready? Do you see how I didn't give you the box? Because to some extent, I might put the box on some questions on the test, but you might have to draw the box yourself. Can we, now, some of you, this is dangerous. Draw the box for number 15. What did I fill in to the box from number 14?
9.
Okay, the 9 was something that I put in. Was the 9 up here to begin with?
No.
Okay, so this is where it gets a little dangerous. Before you do the box, my advice, ready? The x squared is good. I want that guy. The 8x is good. I want that guy. But I want to make my own third number. And I want to make my own third number. So can you guys put the 10 over here off to the side? Instead of moving it to the other side, I don't have a 0 like we did when we were solving equations. There's a y. We're going to kind of leave the y guy there. Look at the top of your page. The y guy is a part of vertex form, right? But I'm going to move the 10 off to the side, but hold on, wait a minute. I can't just randomly add in a number. My equation will be off balance. So what did we, it's okay, he'll fix it. What did we do yesterday? When we added in the 9, what else did we do? Yeah. To keep it balanced, we're going to add in, which is good, but we have to subtract somewhere else. So I want you to put a plus and then a minus. Okay, can you guys just pause and do that next step for number 16 and 17? Can you take that third number and move him off to the side and say, I'm going to make my own third term, but then be like, ooh, stay balanced. I have to subtract that blank somewhere else. We haven't even filled it in yet. Some of you might be like, wait, I know how to complete the square, so maybe you can fill it in. But can you just do that step of taking that third term, separating him from the rest? Because this, guys, if we don't separate him, your brain's not going to realize we're trying to fill in a random blank that wasn't even there to begin with. So I want you to see another example before you read. Okay, now be careful. If you don't set this up, it's very possible that you're going to do something like put the 9 in and maybe even do it perfectly, but then you're going to mess yourself up because you're not going to put it somewhere else. So that's why I'm having you put the 2 blanks, because it's going to tell your brain, hey, especially if you have like a colored pen, whatever we fill the square with is going to go here and here. Okay? Now, some of you, I walked around, and some of you are filling your square because you're like, wait, I know how to do that. And so, check it. Would you guys know to put x squared with a 4x and a 4x?
Yeah.
Right? X squared, then split the 8x into 4x and 4x. What number do I want in that blank? Yeah, I want 16. Remember, just 4 times 4.
16.
I want 16. Now, hold on. If I've set myself up for success, ooh, hey, there's a life lesson coming in here. If I've taken time, if I've slowed down, if I've thought ahead, if I've put my blanks, I've set myself up for success. I know what goes here. 16, yeah?
Right.
Now, what happened next? Next, we put in parentheses to say, oh, hey, you're the perfect square. You're the guy that comes out that I can factor to look like. Look at the top of the paper. Remember what we're trying to make it look like? We're trying to make it look like that nice little perfect square with an A maybe in front and a K on the outside. And K is the answer for our next blank. K is who I need. So check it. I just made him able to factor, depending on how your brain does it, to that perfect square. How we doing?
Good.
But then what else is there? What's 10 minus 16? Negative 6 or minus 6. And the y's in front. Guys, compare it to the equation at the top. How close does it look? Very close. Who's your A? He's technically 1. He's kind of chilling in front even though he's not there. Who's my H? Negative 4. Wait a minute. Who's the only guy I even need to plug in though?
6.
Careful. Did you guys write down the hint yesterday that we always stay the same on the outside? Or backwards on the inside?
Why minus 16?
We're not. Oh. Isaiah. We were talking about the importance of being balanced just a second ago, with especially number 33, where there was the mistake of them adding the 16 and not adding it on the other side. In this one, because of the way the equation looks up above, because we're trying to get it to look like that vertex form, we don't want to be messing up this side. So instead of being able to add the 16 here and here, think ahead. Adding 16 on this side is subtracting 16 over here. So what we're doing is we're just keeping it all on one side so that we can make it match our nice vertex form from before. And so what we're doing instead of adding on both sides is we're adding and subtracting on the same side. It's like a creative math trick that we can sometimes use.
I don't know.
Dun, 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 dun. Well, because technically what we're looking for is what, and this is actually something that's really tricky for calculus kids that haven't had an algebra lesson like this. There are really complicated like application problems that ask or need like, hey, what's the lowest your cost can go if your business is doing all these things? Or what's the highest your profit can go? And they don't, I mean, sometimes they care about the where it happens, which is the X, but a lot of the times they just care about the actual value of how high it gets or how low it gets. And so what we're doing is kind of preparing you guys with some of this vocab of, okay, yes, it's a parabola, and yes, there's like a vertex, but what does it mean? This parabola can only go as low as -6. So it's kind of preparing you for like, not that we have to deal with any of those really hard word problems. And for the most part, I let you guys kind of skip them just because we're building a really strong foundation on our skills. But anyway, yeah, we're just answering how low it goes or how high it goes. How low did this one go? That K guy, the Y. How low does this guy go? The K guy, the Y. So we just put those two together and we got it. So in case it helps a few of you guys, this factoring comes from our perfect square trinomial, and the K comes from combining those two numbers. So you guys help me out. We have 2 more examples to do. I'm going to zoom in. I'm just curious. We've already done the what's the shape and is it a max or is it a min? We now need to go through the process of finishing the problem like we just did. Let me zoom in a bit. My question is, well, hold on. You guys drew your boxes already. You're a little bit ahead of me, right? Okay, I'll get my box. After we draw the box, what's the next step? Danny, what's that?
So if it's negative, it's minimum.
If my leading term is a negative, it's down, but down means that there's a high point. Yeah, so the negative means down, but the down always, like if you look at the picture, has a highest, which means maximum. There you go, Kayla's got you. Wait a minute, hold on, what did we do next? What did we do in number 14 and 15 after we drew the box? Oh yeah, we want to go to, okay, we do want to go to the square, but actually before the square, do you guys remember that we set ourselves up for success? We went ahead and we wrote the first term, which is the x squared. Oh, but he has a negative in front. That's kind of weird. And then we did the 14x, and then we did a blank, and then we did the negative 20, and then we did a blank. Remember we had to space it out? Maybe I should zoom in just a little bit. But wait a minute, who's not supposed to be in front of the x squared to complete the square? A 2 or a negative. Well, hold on. So we were going, like, Kayla, the other two, you were able to go straight to the square pretty much. The problem is both of these have kind of illegal people in front. So do you remember what we just did in our harder examples? What did we do with those guys in front to make it legal? We divided, yeah. So here's what we're actually going to do first. We're going to pull out that negative from each of those guys. The negative 20 is still kind of on his own out here. So we're going to pull that negative out, and we're going to be like, sorry, buddy, like, you're not supposed to be there, which is kind of nice. We can do the same thing over here to the 2. And say, sorry, buddy, like, I can't complete the square with you. So I'm going to move that 22 off to the side. These are 2 harder examples where I don't have that nice 1 in front. Now, when I divide the 2, don't I just get x squared plus how many x's? But I divide the 2, goody. See it? Now I can put my blank. So if you had completed the square a little too early, you probably would have put too many things in there. But then, wait a minute, that was pulling out the 2. Don't I also need to pull out, oh, it's a struggle. Don't I also need to pull out the negative on the other side? So then pulling out the negative on the other side, that means dividing. There we go. Pulling out the negative on the other side, that means dividing. Let's see. A negative divided by a negative is a positive. A negative divided by a negative is a positive. Okay, so it's not quite as bad on this one. The 14 stays, just the negative is gone. And I'm getting my boxes back, so I'm a lot closer to being able to do the boxes now that I have that X with a 1 in front. But if you guys notice, I think I'm in a little bit of trouble right now because I'm not setting myself up for success and being balanced. I have an addition in one spot, but I don't have somewhere else in the other spots. I'm going to put my minus over here. There we go. I have to keep everything balanced. So if I add it in one spot, I'm going to minus it somewhere else. And remember, how do we fill those spots? Using that number. So now it's time to complete the square. Now that we have our little x to the 1, we're totally ready to go. So this guy, have you guys already filled them in? We get x squared, and what are our 2's split in halves?
The 2.
7.
Good, 7x and 7x. So what goes in my complete the square box? 49. Yeah, so then Kayla's already like, hey, I know how to factor that. It's going to be x, careful, plus 7, right? Plus 7 squared. Uh-oh, wait a minute. I only filled in one of my blanks. But here's a little bit of a struggle. Do you guys see how there's technically somebody else with the 49 besides just what's right here? Remember, it's technically a negative x squared and a negative 14x. What's the 49 technically? A negative. How do I balance a negative? How do I counteract a negative with a positive? I know, it's weird. So check it. No. The negative stays out here. So I actually do all of my same work. The negative stays out here. But to balance it, I actually have to be like, wait, I'm putting you inside a multiplication with a negative, so I need to offset you with the opposite. What always goes here is the opposite. So a negative 49 plus a 49, everything's balanced. And 49 minus 20 is 29. And that is my, whoop! It gets a little harder when there's a number in front, but maybe you guys will be able to see it here as well. Because when I go to do my 3x and my 3x, which what fills the box? 9. Do you guys see why I'm going to put a negative 18 out here? I thought they were the same number. What's outside acting upon the 9? So 2x squared, 12x, yeah, I know, but who is this 9 when I add him in? He's really an 18, so how do I keep it balanced? With a negative 18. It's a little weird. It's a little weird when we go to filling in the blanks if we've had to pull an A out. It's a little weird. But then, once I have that, it's like, oh, you're just x plus 3 squared, and all I need to do is negative 22 minus 18, and I have it in my head. You guys might do it in your calculator. It ends up being negative 40 when I put those two together. Remember, we're always looking for that k spot when we're filling in the value. Why did I double? Because the 9 is doubled just by where it's written. So I had to offset it with the double. Because when you add 18, I can't just subtract a 9. I need to subtract all 18. So I kind of have to think outside the box and say, wait a minute, it's not really a 9, it's really an 18, and then do the opposite. All right, cool kids, we're going to talk about questions on homework 9.4 Steve, but we have finished all of our worksheets. Go team, you have examples like all of the homework problems the best you can. Bring questions tomorrow. Bye. Thank you for waiting. Your trick that was working on when you had a 0 on that side, because you could divide by 2, divide by 2, divide by 2.